In this video, we're going to look at linear equations. First, let's look at a Cartesian coordinate system. So as you can see here on the right, I have a number line, and this number line is one-dimensional. And on the number line, we can put tick marks, and so we can label them as 0, 1, -1, and so on. So on this number line, we can demonstrate any real numbers. But this can, as we only have dimension 1, it can only describe two directions, either to the left or to the right. So the movement of any objects will be limited on the number line, on this number line. But in real life, we actually live in a three-dimensional space. For most of us, we live on the ground, on the surface, and so we can use two-dimensional space to describe our movement. So as you can see here, we're gonna draw another vertical line which intersects with the horizontal number line. So now we have not only left and right, but also up and down. So we can also, for each number line, the horizontal number line, we're going to call it x-axis. We can still label the tick marks. And on the vertical line, we call it y-axis. And we put some tick marks here. And the intersection point, we call it origin. All right, so with the two intersecting lines, we can describe the movement of any objects. So for example, let's say at this point, so we can see that a reflection on the x-axis, which is 3. So we can write down the first number 3. And if we look at the reflection on the y-axis, we got 2. So as you can see, if we start from origin, we're moving over 3 units and up 2 units. And notice these two numbers form a ordered pair. And the first number, we call it, since it's a number on the x-axis, the horizontal line, we call it x-coordinate. And the second number here, we call it y-coordinate. And so with these two numbers, we will be able to describe, to locate any object. And so the other way, if we are given two numbers, let's say an ordered pair, for example, if we're given a -1, +3, and since the first number means the x-coordinate and the second number is the y-coordinate. So on the number line, first we found the x-coordinate, -1, which is right here, and then we're gonna find the y-coordinate, which is 3. So we're gonna look at the intersection of these two, and that gives us a point that would be the location of -1 and +3. The other way to look at it is because, so we always start from origin, and then we're gonna, since x-coordinate is -1, so we're gonna move to the left 1 unit, and the y-coordinate is 3, so we're gonna start from here and then move up 3 units. And so we can get this point. We found this location. So notice here we have two different concepts. And the first concept is a geographic concept, that is a point. So as you can see here, we have 2 points. This is a point, and this is a point in geometry. But each of the points can be represented by a ordered pair that is that's numerical values or an algebraic view. And these two different subjects are connected by the xy coordinates. So again, a point is a geometric concept, but an ordered pair, it's like a algebraic point of view. And then this point, same thing. We have an ordered pair to correspond to it. So with the coordinate system, we are able to connect geometry and algebra. So an algebraic expression can be graphed as a geometric shape, and vice versa. A geometric shape can be expressed in terms of an algebraic expression. So now let's look at the algebraic expression here, which is y equals negative 3x plus 4. So as you can see here, we have two variables, x and y. And this is different from the equations we solved before. On the left right here, you can see we have 2x plus 1 equals 5. And we know how to solve for x here. But instead of, if somebody tells you x equals 3, this is a solution that they found. And instead of solving it yourself, you could plug the solution in here and to check if it is satisfies the equation. So I'm going to replace x with 3 and copying everything else. As you can see, 2 times 3 gives us 6, and 6 plus 1, and then 6 plus 1 gives us 7. And apparently 7 is not equal to 5, which tells us x equals 3 is not a solution of this given equation. Of this equation, 2x plus 1 equals 5. As you can see, in this equation, we only have one variable, x, one unknown. So we could subtract 1 and divide by 2 to get the solution. Actually, it should be x equals 2. So if we solve it and we subtract 1 and then we divide by 2, we end up with a correct solution, which is 2. And you can see if I plug 2 into the original equation, 2x plus 1 equals 5, I replace x with the correct solution 2, and you can see 5 equals 5, because 2 times 2 is 4, 4 plus 1 is 5. So the left-hand side equals the right-hand side. So that tells us this is the correct solution. Now, if we look at the equation on the right, and we have two variables, and so the solution, each of the solutions needs to have two numbers, because we have two unknowns, x and y. So that is a variable, and that is also a variable. So we have two variables, or you can say two unknowns. Over here, the equations we solved before, we only have one unknown. So we were able to get a solution, get x by itself, which gives us the answer 2. And this is actually the only solution we found. Now, but when we look at the equation with two variables, so we have to find a number for both x and y. So how do we solve for the solutions? Now, before we do that, we are going to first test these ordered pairs, whether they are solutions. So somebody already tried to solve this equation, and they found some of those solutions, and we just need to test whether each of them is the correct solution. So as you can see, we are given 5 different solutions here. So how do we check that? It's very similar to what we did here. So remember from the previous video, an ordered pair always has the first number as our x coordinate and the second number as our y coordinate. So we can label x and y, x and y, x and y, and xy. So what we need to do is we start with the first pair, ordered pair. We're going to plug x equal to 1, y equal to 1 into the equation. So I'm going to test the first one, y equals negative 3x plus 4. So I am going to plug 1 because x equals 1. This one tells me x equals 1. So I'm going to replace that x with 1 here. And y is also equal to 1. I'm going to replace y with 1 there. And now when we, the left-hand side is a single number. I'm just going to bring it down. The right-hand side, we can simplify it. Negative 3 times 1 is negative 3 plus 4. And negative 3 plus 4 is equal to 1. So that tells me after I plug 1 for x and 1 for y into the equation, I did have an identity, which means the left-hand side equals the right-hand side. So that tells me, yes, 1 and 1. Or if you rewrite it, you could also write it as x equals 1, y equals 1. But these two together is a solution of that equation. Because the equation has two unknowns, we have to find numbers for both unknowns. So similarly, we can do the same thing to plug in the other pairs into the equation and to check whether these are solutions or not. So let me try one more here. So let's try the second pair. So we're going to plug, since y equals 0, so I'm going to replace this y with 0, and x equals 1.5. And now let's simplify this. And notice 1.5 times 3. We ignore the decimal point, so we multiply 3 and 5, get 15, and 1 times 3, 3 plus 1 is 4. And we put the decimal point back, so we got 4.5. But since we're multiplying negative and positive, we should get negative and plus 4. And notice the right-hand side, negative 4.5 plus 4 gives us negative 0.5. And they are not equal to each other. So that tells me this is not a solution. So I'm going to just go ahead and label here. So the first one, after we've verified this is a solution, but the second one is not. And similarly, we can check the others. The other way to do it, if you want, you can make a chart. And so this probably is going to be more clear. And so first I write down, I copy down all these given solutions. And 1, 1, 1.2, 1.50, and 3, negative 1, 0, 4, and negative 1, 5. So I'm going to check each given solution, see if they are correct or not. And you don't have to do the second column, third column, but what I did here is trying to make it very clear. So x is equal to 1, y equals 1 in the first case. In the second case, x is 1.5, y is 0. And x is 3, y is negative 1, x is 0, y is 4, x is negative 1, and y is 5. So that way we can plug in here. So again, I already did the first two, so I'm just going to plug in here a little quick. So y is 1. So make sure when you plug in the correct numbers, because y and x kind of like in a different order. So 0. And again, we already kind of checked this. We did find out, yes, y equals 1. 1 equals 1. So that tells us this is a solution. So I'm just going to say 1 equals 1. So that's correct. Yes. And the second one, after we plugged in, we actually found out the right-hand side actually equals negative 0.5. So this will be no. So we can continue to check the others. So y is negative 1. In this case, x is 3. And then we simplify negative 3 times 3 is negative 9. Negative 9 plus 4, that gives us negative 5. So it's saying negative 1 equals negative 5. Again, that's not an answer. And the next one, y is 4 and x is 0. And notice that any number times 0 is 0 plus 4 is equal to 4. So we do get 4 equals 4 in this case. So that is a solution. Finally, y is 5 and x is negative 1. And notice that the right-hand side, negative 3 times negative 1 is 3. Positive 3 plus 4, that's 7. Again, that's not a solution. So from checking, plugging each pair of numbers into the given equation, we found out we have 1